In this video, we will demonstrate how to do experiments with SOAP-based web services using Spring Cloud. When building an SOAP-based web service, the way we build a new project using STS is slightly different. In the case of building SOAP-based web services, rather than building a project using Spring Starter project, we will be using import Spring Getting Started content. And this will help us understand SOAP-based web services and the various artifacts of such services. So here we will be importing Producing Web Services. We will uncheck the guide and click Finish. It is now creating two projects. The first one is Initial and the other one is Complete. It builds the workspace and we can explore it further after it completes building. Here we can see that it creates two projects. We can also observe that we are provided with JAXP artifacts that we have to create. Now, JAXP artifact is nothing but XML to object mapping, which is described here. So for a country, we have name, population, capital, and currency as attributes. We also have XML elements here that we can bind with these attributes or members with the appropriate XML elements. So whatever we want in the form of elements are bound here. Similarly, there is getCountryRequest and getCountryResponse, and they provide the XML structure for the request and response tokens or packets, which will be encapsulated in an SOAP-based message. So where is the service? We can observe another application, which is Hello, and under Hello, we have a country endpoint. Now this endpoint defines certain methods, which can be called in order to facilitate interaction with endpoint. We can see the getCountryResponse, which has been defined in the form of JAXP object. Now users will be able to call the getCountry passing the getCountryRequest, and it will return the response. The response will be in the form of XML, powered by SOAP. Then we have the country repository, which contains various countries as part of the repository from where the services will be fetched. And here it's using stereotype called as component. There is another important class, which is the Web Service Configuration class, which provides information about what the endpoint will be. So here the endpoint is WS. The port name is country's port, and there's a schema countries.xsd, which is being used in our JAXP elements as well for validation. Now that we have explored all the important classes, we will start the application and run it as a Spring Boot application. So let's bring up the console. We can see here that it has launched the application and the name of the application is Hello. It is also specified where the application is hosted. It's being hosted at localhost, and the port is 8080. Let's bring up the browser and launch the specific port. Now, since it's an SOAP-based web service, it's not displaying anything here because it generates SOAP messages. But when we navigate back to the console, we can see that the app has been initialized and completed successfully. From this video, we learned how we can use Spring Cloud to configure and build SOAP-based web services that are not necessarily accessible from a browser, since they internally use SOAP as a payload. In this video, we are going to discuss and demonstrate the various forms of REST operations or methods that can be performed using JSON. Now, there are various operations that we can perform on the resources that we have made available at RESTful Web Services. And some of these operations are create, update, insert, delete, and so on. Here we have launched Postman. And in Postman, there are various operations or methods that we can perform or execute. In case we want to send a GET request or perform a GET operation on a particular RESTful web service, we will be selecting the GET function followed by the specific URL, which will guarantee response value if there are any resources. For example, we'll specify a URL here, http localhost. followed by the port and env. After we have specified the endpoint and click Send, it retrieves and returns the value in JSON format. We can find various values like profile, server ports, local management port, which is 8091, local server port, and it displays all the features of the server. Similarly, if we want to send another GET request in order to check the health of the server, we will specify health after the port and click Send. This request pulls up all the health parameters of the server on which the particular service is starting. So this is how we will actually be using GET in order to get the details of our service. Now assume that we want to create a new resource. Let's also assume that we already have the URL that contains certain data regarding a particular scenario. In our case, we'll assume the scenario to be a hotel, and we will create a new hotel resource. To create this resource, we will be using the post method or function. Since we already have the URL, all we need to do now is to specify the data or the payload that needs to be passed along with the URL. We'll pass example and v1 with whatever the URL is and ensure that we have the right URL of the service which we want to use to add resources. Here we are using resource hotels. By default, it will accept JSON. We are also provided with an option to specify some body or some value to it. In order to specify the value, we can use key value. We can also use bulk edit here by specifying the raw data. In this demonstration, we will be using the key value edit and start passing the required data. For example, I'm passing the name as AAA. We can add another value here, and we'll use description as the key. The description can be made up of some random value for now. The third value that we are passing here is city. So the post method typically helps us add new entries to our RESTful web service container or the data container. We'll finally include a fourth key, which is rating. And we now have a service with these 4 arguments. Now, after passing all these arguments and specifying all the key values for the resource, we'll click Send. We'll notice here that sometimes we get the 415 status. This status specifies that there is an unsupported media type included in the resources. This error basically appears when the type of media that we are using is incorrect. Let's try another media type and try posting these resources again. Here we still get the 415 error status telling us that the media type is still unsupported. Now there are various media types that we can still try and use. For example, instead of form data or XWWW form URL encoded, we can pass raw JSON feed of the key value in the right format. So depending on the type of method and depending on the support provided by our web service, we will be able to apply the right create, insert, update, and delete method or function using various URIs for JSON. There are certain web services that won't support the post function and may only offer the get method or function. In order to test whether this web service supports post method or not, we will specify a certain value here. So after specifying the values, we will change this to JSON, and it'll notify any invalid entry that it finds. Let's correct this and make it valid. We also need to ensure that our entry is correct before processing the post method. Now let's click Send. So now our JSON payload is added, the connection is closed, and the data is chunked. And this is how we will be using the post method or function. Similarly, if we want to delete the resource, we will be using the delete function. If we want to update the resource, we will be using put. To copy or to change some header value, we can use head. And these are all different methods that can be applied on JSON using our RESTful web services. From this video, we learned how to manage resources or perform various REST methods using JSON. In this video, we're going to elaborate on the fundamental objective of SOAP and REST and how they differ from each other. Before we begin exploring the differences between SOAP and REST-based communication, let's first understand each of them. We will begin with SOAP-based web services. SOAP-based web services are typical web services that are built using standard HTTP protocol, which is the transfer protocol, but the payload is XML. And that XML is written using a standard that we know as SOAP, or Simple Object Access Protocol. Now, SOAP is W3C compliant, which basically means that it's a standard which is adopted by all the web service providers. So, if we are building a web service which is SOAP-oriented or SOAP-based, it will be W3C compliant, and it will be similar for all the different web service providers. So the consumption of that web service will be made available to all the different providers because they are using the same protocol. SOAP-based web services heavily use XML, so they're XML-powered web services where all the different standards, whether it is SOAP, description language, which is WSDL, or payload, are all in the form of XML. SOAP comes with certain standards that ensure all our services are discoverable. And so, if a client wants to discover a service, they can use a WSDL document. Now, WSDL documents contain web service descriptions using a particular language, which is in the form of XML, and that particular language is what we call WSDL. We have to make sure our services are registered to ensure they are discoverable. And in order to make our services discoverable in SOAP, we can use UDDI or EBXML. And these are the standards that we will be using to build XML-based web service registries. So after we've built a service, we will register it with UDDI or EBXML registry. Following the services, consumers and clients can discover the service from UDDI depending on certain keywords. Now, in order to facilitate content transfer from one end to another, we can use SOAP, as it ensures the payload of the request contains a header, and that header will contain non-functional data like security, user info, and so on. Similarly, after executing the service, when the server sends a response, they will also follow SOAP protocol. This will ensure there is a proper handshake and rich payload is updated or transferred between the client and the server along with the right headers. Similar to SOAP, we have another approach that we can adopt in order to build a web service, and that approach is called REST. REST is a lightweight alternative that can be used in order to build our services and make them available to customers. REST also uses HTTP protocol, so it's an undefined interface, as opposed to SOAP. In SOAP, we can define multiple interfaces, but in the case of REST, we have an interface which is HTTP. We all know HTTP is URL-based, and it provides a simplified form of web service representation. Now, REST uses HTTP 1.1, and the interface contains various methods like GET, POST, PUT, DELETE, and so on. And they are typically used to help us perform CRUD operations. REST implementation is illustrated in this sample figure. We have an HTTP client and an HTTP server. And on the HTTP server, there are REST-aware applications being deployed. The HTTP client makes a request which goes over the HTTP packet, and the other requests are GET, POST, PUT, and DELETE that are a part of the HTTP specification. We can send the payload in the form of XML or JSON. Now we have to decide whether we would go with SOAP or REST-based web services. In order to understand which one is better or works better in a particular situation, we need to understand their respective benefits. Now, SOAP provides platform and language-independent capabilities. It works in well-distributed environments where we can facilitate load balancing and scalability. SOAP has fault tolerance, so there is built-in error handling capability. SOAP also provides pre-built extensibility environments because it has been in existence for a lot longer. and almost all the vendors have implemented SOAP specifications quite well. The other important benefit that SOAP provides is that it not only works with HTTP protocol, but it also works with other protocols like BEEP or SMTP. So in case if we want to make our services available over various carriers apart from HTTP, we can go with SOAP-based web services. Now with REST, we understand that it is HTTP compliant. It has a fixed number of verbs, so it provides simplicity in terms of web service development. And we don't need any expensive tool to build web services using REST. The learning curve associated with REST is smaller because it takes or it originated from HTTP, and it follows only HTTP interface. REST is also very efficient because it's lightweight and it does not have heavy payload like SOAP. And since it does not have heavy payload, it's faster than SOAP. And finally, REST is based exclusively on web philosophy or web technologies. So in case we have to perform operations like create, update, insert, or delete, and if we need to transform our services into resources, REST will be a better choice as compared to SOAP. Now, we need to understand a very important concept in REST, and that is the REST maturity model. And in this RMM model, they have grouped it into various categories or various levels. The first one is level 0. In level 0, the system will focus on services with specific URIs or endpoints that can be made available in the form of HTTP verbs like post, put, get, and others. Then we move to level 1. Here we have to identify resources. For example, customers will be treated as a resource, and we will introduce URIs for each resource. Now, if we want to update, insert, or delete customers, we will be specifying it as a resource, and that resource will have multiple URIs, where each URI will be responsible for a particular functionality. The next level is level 2, and in level 2 we have HTTP verbs and HTTP response codes for each service or resource. There are certain response codes signifying certain status. So for example, the code 200 signifies success, and 300 signifies redirect. So this level relies on better communication in terms of providing rich response codes. Now the final level is level 3, which is basically HATIOS. And HATIOS stands for Hypermedia as the Engine of Application State. Here, it ensures that we are using hypermedia to provide the benefits of making our services granular and portable. So with REST maturity model, we can implement REST by providing elements from different levels. Now that we've understood how SOAP and REST web services work, let's quickly compare a communication implementation of SOAP and REST. To facilitate this comparison, we will be using this sample implementation example. So here what we have done is, we've hosted our RESTful services on Apache Tomcat. We are also providing endpoints or URIs to these RESTful web services for resources, and those resources are bound with the tables that are in the database. Now we can place requests for particular RESTful services using various interfaces like IoT devices, sensors, smartphones, and web portals. The request will pass through the Apache web server to implement security and load balancing. So here the web container is capable of providing direct access to the resource from any device. We won't need any extra plugins and any dependent jars or files to communicate with the RESTful services. We won't need any stub either because we have HTTP and these services are accessible over HTTP. So from this video, we learned how REST and SOAP are different from each other. We also learned under what circumstances or requirements we can choose to use either SOAP or REST. In this video, we're going to demonstrate how to configure ActiveMQ to send messages. In order to configure ActiveMQ, we will need to build a new project using the Spring Starter project. We'll name this project as ActiveMQ Messaging. Now let's add the right set of dependencies. We're looking for the right messaging dependencies, so here we will add JMS, which is the messaging dependency. Apart from this, depending on the complexity of the service, we can add various other components that can help us build a boot application. So we will be adding one more component, which is web. Let's close all the other applications that are currently running on STS while we wait for the ActiveMQ messaging application build to complete. Now the build is complete, and when we explore, we can see it includes a class in the main folder, and that class is a boot application, and it is responsible for managing the dependencies and ensuring the application is up and running. We will also find an application.properties file, which is empty as of now. Now we will explore how we can configure ActiveMQ so that we can start sending messages to it. And in order to do that in Spring, we can enable an embedded ActiveMQ that we need to configure. We will discuss some of the configuration parameters of ActiveMQ here. As we can see here, we have an ActiveMQ followed by the broker URL, which is a VM and indicates that it is embedded. We will also find in memory non-blocking redelivery and the packages. Now we will rename the application.properties file to application.yml. Open the file, right-click, then click Refactor, and finally rename. So here some of the properties are non-blocking redelivery, which is true. We can specify the trusted property as Skillsoft. We will eliminate the trusted property and set the trust all property to true, so that this is open for everyone to send messages. After we have configured ActiveMQ, the next step is configure JMS, so that you can start sending messages. Now in order to configure JMS properties, we will be making some entries in the configuration file. And these are some of the important entries that we will make here. The delivery mode here is showing as non-persistent. We will get this changed to persistent so that the messages are retained and save it. We will stop all the running services here. So now we have configured our ActiveMQ. We can start it at a particular embedded VM port, and it also understands JMS properties. We'll quickly increase the receive time out to 1000 and save it. So after configuring our ActiveMQ and JMS parameters, we can start building the application and enable JMS Listener if we want. And depending on the type of application that we want to build, we can enable building those types of applications too. Now let's specify the logic that will be used in order to send messages in the queue. To do this, we'll add a new class. We'll name the class as SendMessageToQueue. After creating the class, we need to specify the logic to send messages, and in order to send messages, we can be certain that the Spring classes can help us send and receive messages. We'll declare JMS template. Now JMS template is bundled with Spring to help us send messages. After we have declared JMS, we will ensure that it is auto-wired, so it can be configured automatically without us needing to configure it manually. Now let's write a method, which is public void send, and specify the messages that we want to send. We will use JMS template to send message, and so we'll declare JMS template.convertAndSend by specifying the destination and the message. The destination is Q1, and we will specify the message that we want to send hello. Now that we've completed writing the logic for sending messages, we'll run this application as a Spring Boot application. We can see here that our ActiveMQ application is starting, and after the application has started, there will be an ActiveMQ application element that can receive the messages sent using ActiveMQ. We can now stop the application and plan how we will collaborate with ActiveMQ in order to send and receive messages. From this video, we learned how we will configure ActiveMQ so we can send messages using ActiveMQ. In this video, we are going to demonstrate how to provision codes that will provide the logic of receiving messages from ActiveMQs. So what we need to do is to configure a project with capability of having ActiveMQ messaging enabled to it. We will start a new Spring Starter project. We'll name it as ActiveMQ Messaging 2. Now add ActiveMQ, click Next, and Finish. Now that the project is built, we'll create the configuration file to specify Spring-related properties. We'll create an application.yml file from the resources. After creating the application.yml file, we will make certain important entries to configure an embedded ActiveMQ. We are pasting the properties here. We can see that the embedded broker persistence is set to false. We will be removing the trusted properties from here and set the trust all properties to true. This will ensure that all the incoming messages or the messages are being read by all. Now let's make sure these values are as per our need, and assuming these values are what we need, we will now configure JMS, which will be responsible for interacting with our queues and read messages from the queues. We will also be able to use JMS templates by configuring JMS. We will paste the properties here and change the delivery mode to persistent. Click Save to conclude configuring JMS and ActiveMQ. The next task is to write the logic for receiving messages from a configured queue. Now, Spring Framework provides a listener which will be responsible for listening and displaying the message from the designated queue. We will be creating a class in order to facilitate this. Let's name the class as Message Receiver. Now we will specify the required logic in order to ensure that whatever messages are being sent to a particular destination are received. We will declare static string queue name followed by the name of the queue. Here let's assume it's queue. So what we are doing is we are specifying the name of the queue that we want to target for receiving the messages. Then we will need JMS listener. So let's declare JMS listener as well. This listener is important as it will ensure that we are able to read the messages from the destination. Let's configure the JMS listener further. We will specify the destination is equal to queue name. Now we need to write the method which will actually process the message which comes from the particular read activity. So let's write method public void with the name receivedMessage and specify payload. We'll make some changes here. So now we will directly specify the name of the particular queue. We'll annotate the payload for receivedMessage. This is the payload which comes as part of the message. We can specify the type of payload that we are going to receive. Here, the type of payload that we are specifying is string, and we will be consuming those string messages. We would like to read the headers as well, and we have another annotation which helps us get the headers of incoming messages. So now we have written the logic that will help us receive the message along with the payload and header. We can now consume the message, or we can use the message the way we intend to. We can declare some statements specifying what we want to do after consuming the message or after we receive the message. So here we will declare activate task once you receive message. Now this task will be executed whenever we receive messages. We can also print the payload or print different elements of headers that we want. For example, we can say headers.getTimestamp, so we can get the timestamp when the message is received. Our application is now ready to receive the message that we will be sent to this particular queue. We will run this application. As we can see here, we haven't configured it, But this demonstration will help us understand how to kickstart and write codes in order to quickly consume incoming messages from a queue. So here we will observe that ActiveMQ messaging application is now running. From this video, we learned how to set up applications to receive messages from a particular ActiveMQ queue. In this video, we will demonstrate how to create a POJO and use ActiveMQ to configure it for synchronous messaging. We will start a new Spring Starter project. We'll name this project as ActiveMQ Messaging 3. We'll add messaging component ActiveMQ along with the web component. We'll click Next and Finish to complete building this project. Now we have to define the POJO that we want to use as a component to be written to the queue. But before we do that, we need to configure and define connectivity properties for the ActiveMQ. So in order to do that, we will first create a file for the SRC resources. We'll name the file application.yml. We will now configure ActiveMQ in this application.yml file. For example, if we want to use embedded ActiveMQ, we can add the specific properties that we want to specify. We will write those specific properties here. As we can see here, we have specified where the broker URL is along with the in-memory. We also need to ensure that it's trusted by all. And to do so, we will say trust all equals to true. This will basically ensure that anyone can send messages. We've also added the property block if full, so in the event that the queue is full, it should be blocked. After specifying these properties to configure ActiveMQ, we can begin coding to define the POJO. We'll begin by creating a new class. We'll name the class as OrderMessage. And this will be the POJO that we will define, and it will also contain messages. Now we will declare string message, following which we will be adding the getter and setter methods, along with the constructors. So now our POJO is ready. The following task is to write logic for sending messages, and these messages that are being sent will be the instances of OrderMessage. We will create a class the same way we created OrderMessage. We will name this class as OrderSender. Then we will specify the logic of sending messages. We will have to make sure that this particular class is a service. We can simply specify service, following which it will be treated as a service class. We will also define JMS template, so as to ensure we are provided with an interface to write messages. Then we will specify a function that will take the responsibility of sending the POJO. The function is public void send order message. And we will be using JMS template to send the message. So we will say convert and send, and then specify the destination. The destination here is Q2, and we are specifying what message we intend to send. So let's enable JMS now. In order to enable JMS, we will be creating another class. We will name this class as ActiveMQConfig. We can now specify and say enable JMS to enable JMS here. We will also need this class to be treated as configuration class so that all the configurations will be read, and this will be treated as a configuration class or configuration interface. So here we can specify the logic to handle the messages. We will declare the logic to handle messages here. And this is how we can use POJO to send messages by configuring application.yml and ActiveMQConfig, depending on the logic of handling POJOs that we want to implement. In this video, we're going to demonstrate how to build a microservice and how to configure the particular microservice for execution or to run the particular microservice. We'll start by creating a new project using Spring Starter Project. Let's name this project as Service Sample 1. Now, let's add the required or desired components like Web Services, Web, Eureka Server, and Eureka Discovery. We will also be adding a Cloud Core component, which is Cloud Bootstrap. Click Next and Finish to create this project or service. After the service has been created, we will go ahead and create a resource file. We'll name the file as application.yml. And then click Finish to create the file. Now we have to configure our client, indicating the port where the service will run and the server instance. Let's specify the port for the server. Since we want this to run on the local host, we'll just specify the port. We can also specify certain other properties and custom attributes like info, endpoint, and others. For now, we'll specify a name for the service along with some basic info. So now we have the required information for the service to run at this particular port. Now we need to build the service itself. We will be creating a class to build the service. We'll name the class as Book and click Finish. Let's add some attributes to this class like Book ID and Book Name. We will also generate getters and setters method, along with constructors. Now we can have the resource for which we are going to create the service. We will create a class again and name the class as Book Controller. And this class will be responsible for controlling the book operations. Then we will annotate this particular class using the annotation REST Controller. Now, after specifying the annotation, we need to declare some methods that will provide some value or return some data. So we'll say public get book. We are defining a method here that returns a book, followed by return new book and specify some ID or some name for it. And since we want to get the book name, we can also specify get book name. The next step is to configure our service sample IMPL, which is a bootstrap. Now we need to ensure that our service is discoverable. And all we need to do to make our service discoverable is to enable Eureka Client. So now our tasks are done, and all we need to do is run the service. Now in order to run the service, just open the service application and run it as Spring Boot Application. Here we'll find that this service has started at a particular port that we specified earlier. And this is how we can run the service. It will try to discover the service at a particular registry. Here we can see that the connection is refused, and we are unable to connect because we didn't configure the service registry. So from this short demonstration, we've learned how to build a service and how to run that particular service after having built it. In this video, we are going to demonstrate how to build a discovery service using Eureka. Let's begin by creating a new Spring Starter project. We'll name this project as Service Discovery Server. Then click Next. We'll select and add the required components here. We'll add Config Server, Eureka Server, Eureka Discovery, and Cloud Bootstrap. Let me go back and add Web. Then click Next and Finish to start building this project. While the project is being built, let's close all the existing tabs. Now we need to provide a configuration file which can help us specify certain properties that we will need for the discovery server. We're going to follow the concept of YML, So we'll create a new YML file and name the file as application.yml. We must ensure that it's application.yml because the Spring Bootstrap will search for it. We will be making entries here, and the entries will be the properties that we will specify to the server. Let's import the properties here. Let's change the port. Instead of 8761, we'll use 8762. The host name is specified as localhost. We've set the property register with Eureka to false because we don't want this to get registered to itself. And then the fetch registry is also set to false. We have specified the default zone as it will be used in order to get the URI of the services that we will bind with. Now we have to customize the service registry, and for this we will use the Bootstrap application, which was built with the project. We will then enable it so that it can be treated as a Eureka server, which we will use as our discovery server. So let's say enable Eureka server, and then save the files. Now let's run it as a Spring Boot app. And click OK. Let's bring up the console to check the build activity. Here we can see that Tomcat is on port 8762. We have to verify whether Eureka Service is up and running or not. We will open a browser and specify the URL or the endpoint of the Eureka server, which is hosted on localhost at a particular port. We can confirm the port from the console as well. And as we can see here, 8762 is the port being used. Let's specify the port and bring up the Eureka server. Here we can see that the Eureka server is finally running. The environment is test, and it has captured the current timestamp. We are also provided with the information that there are no applications registered to our server currently. From this short demonstration, we learned how quickly we can build a discovery server using Eureka. In this video, we are going to demonstrate how to bind a service with an existing registry. Now, in order to bind a service with an existing registry, we need to know where our Spring Discovery Eureka server is running. After we have discovered or known where the Eureka server is running, we will need to make a note of the IP and port. So as of now, the port is 8762 and the IP is localhost. Let's now build a service and register or bind it with this particular Eureka server, which is already in a running state. We will be building the service using Spring Starter Project. We'll name this project as Service Client and add required components. For this project, we'll add Web, Eureka Server, and Eureka Discovery. Click Next and Finish to manage all the dependencies for this particular project. After the project has been successfully created, we can start building the resources. The first thing we have to do is write a configuration file so that this service is aware with whom it will be bound to, and in this case, it is the server. We will create an application.yml file. Then click Finish. So we will be configuring this file in order to bind this particular service with our Eureka server. So here we'll make some configuration entries that are essential in enabling the service to work at a particular server for discovery. Let's import the entries here. We have to ensure that the port is correct. We have specified the Eureka client, and we have also specified the renewable interval, which indicates when we should get the heartbeat exchange from the Eureka server. Let's ensure we are saving this configuration file. Now we can begin building the service, and in order to build the service, we will create a class. We'll name this class as Book. Now we will add some attributes to this class. Let's add book ID and string book name. Now we will generate the required methods, and they are getters and setters and constructors. So now our class is ready, and this will be the element of negotiation for the book service. The next task is to specify controller. For this, we will create a new class, and we will name the class as Book Controller. Now we will declare some methods that the service has to work on. The method will be public book and specify getBook. And this method will return a new book. We will add the right constructor so we can specify the property's value here itself. Now we will need to ensure that this class is treated as a service. We will specify an annotation for that, and the annotation is REST controller. And finally, this is the service which we would like to bind. Always ensure that we are specifying the annotation at the right level and the right scope. The REST controller scope is the class scope. So after we have done this, we need to configure our boot application so that it can enable Eureka Client, read the properties file, and bind it with the service. We will specify Enable Eureka Client annotation and click Save. So now our class is ready to be bound to the server. It will load the configuration from the configuration file, and it will try to bind that particular service, which we have defined here at this particular Eureka server. Now we will run it as a Spring Boot app. Let's open the console here and see what the book service instance has registered at this particular port and IP. We need to ensure that we have access to the Eureka server. We can see that initially there are no services registered here. Refresh the page and we will notice our book service instance is now registered. So from this short demonstration, we learned how to create a service and bind it with Eureka Server. In this video, we're going to demonstrate how we can configure and activate load balancing in microservices using Ribbon Client. We'll begin by creating a new Spring Starter project. We'll name the project as Load Balancing. Click Next. We'll add some components from among these. Let's add Web and Ribbon. This component, Ribbon, will help us implement load balancing in our services and applications. We'll also add Eureka Discovery and Eureka Server. Then click Next and Finish to complete building this project. Let's close all the running applications because they may occupy certain ports which we are going to use here. Now we'll specify controller for our project, and for this we'll create new controller class. We'll name the class as Web Controller. Let's specify some properties for this class and configure it. We'll import the codes in this code section. We are declaring @request_mapping to ensure we get the right context. So we've configured our web controller, which is a REST service. The next step is to create a client for our ribbon. We will be configuring important information about the client so we can provision load balancing and ensure our ribbon is running at a particular IP and at a particular port. And to create a ribbon client, we will be adding a new file in the resource folder of our project. We will name this file as application.yml and click Finish. We will be making required entries in this file in order to configure the ribbon client. So let me quickly import these entries. So here we have ribbon client, hello world, then there's ribbon, Eureka, and enabled, which is set to false. And these are the list of servers that will be used for load balancing. We have to create a configuration class, and that configuration class will take responsibility of enabling the load balancing features. We'll name the class as Configuration. Now, let's configure this class to ensure it's behaving as a configuration class, and to configure, we will import Netflix client. We have also defined certain methods that will help the ribbon client to auto-wire and build a config context. The next step is to configure our Spring Boot application. We'll be using certain annotations that can help our Spring Boot application to inject the required dependencies for building load balance controllers. So let's navigate to our Bootstrap application and use the annotation @RibbonClient to configure Ribbon Client in this application. We will specify a few parameters to the annotation too, and one of the most important parameters is the name. This name should be the one we used in the configuration, and that will be Hello World. We will also be specifying the configuration class that it should look for. This again should be the same configuration class that we've already built. So now Bootstrap app is configured. We will need to configure another controller so that it can be used to balance loads. We'll be using a REST controller, and we will annotate the REST templates. We will be using some popular annotations, and those annotations are load balance beans. So now let's create a new REST controller class. We'll name this as WebController2, and it will be responsible for enabling load balancing using certain popular annotations. Now let's import some of the properties that we'll be using to configure this WebController2. The REST template is indicated here, and this template will get the objects for the particular service using string. There are two important annotations, @loadbalance and @beans, that we're using on the REST template. So now our services are configured to take the benefits of the load balance configurations that we've implemented. Now let's run our project application as a Spring Boot app. Let's bring up the console, and we'll find that our Boot app has initialized and our services are ready to be used. And this is how we configure and work with load balancing in microservices using Ribbon Client. In this video, we will highlight the capabilities of Spring Cloud in managing all the considerations that are required to build architectures and platforms to host our web or microservices. We will explore some of the important components to help us understand how they can help fulfill various requirements for building microservices. As usual, we'll start a new Spring Starter project. Here we have various components that can help us implement different patterns. For example, there are certain patterns here that can enable us to have multiple instances per host. Then we have components facilitating API gateway, client-side discovery, server-side discovery, service registry, self-registration process, and then there's circuit breaker for reliability. There are various messaging components too that can facilitate various ways and forms of messaging. So Spring Cloud provides all of these components in a single bundle, and these components are basically collaborations of various open source components. Now Cloud Config provides a capability of centralized configuration management, so we can use Cloud Config components to quickly build Cloud Server. So here it automatically provides an application which is capable of centralizing the management of our Spring-based microservices. Similarly, if we want to provision service discovery, we can create another Spring Starter project. Here we can add any and all of these discovery components. For this project, we will add these two. If our project requires Zookeeper or Cloud Foundry discovery, we can even add these two components also. Spring Cloud collaborates and provides various components that meet all the essential needs of microservices. When we want to conduct cloud messaging, we are provided with publish and subscribe models as well. We can make use of these capabilities of Cloud Bus and Cloud Stream by adding them to the project. When we want to monitor or trace services, Spring provides cloud tracing components, and we can either use Sleuth or Zipkin client. So depending on our requirement, the features we want to include, or the task we want our service to perform, and the capabilities that we want to enable in our services, Spring Cloud provides us with a single-stop shop to simplify the way we manage our microservices. Similarly, our microservices can be powered by various containers. We can deploy our services in Docker or place it somewhere and use certain container management components. Now, assume that we want to deploy our services on Amazon Web Services. Spring Cloud provides that capability too. So we can use cloud AWS components like AWS Core. We can interact with RDS Service and also use AWS messaging components, which is provided by Cloud AWS and STS. And if we want to come up with database paradigms, Spring Cloud supports various databases along with the built-in connector capabilities. So with all these features and components, Spring Cloud provides impeccable capabilities and facilities to host proper infrastructure for our microservices. Spring Cloud also enables microservices to follow all the distributed patterns that are necessary in ensuring scalability and reliability of our microservices. Now it's time to test your knowledge and understanding of what we've learned in this course. So in this exercise, we will create a discovery service, publish the service, make the service a discovery client, and test the published client in Discovery Server. Now I want you to pause this video and attempt all the exercises, and then come back to view the solutions so you can understand how well you've attempted. Let's start with creating the Discovery Server first. Using STS, we will create a Spring Starter project to begin with. We'll name this project as Exercise 3. Click Next. Let's add Eureka Discovery and Eureka Server. We will also add Web to host our web services. This will be a two-step task. Open the application.properties file located in the main resources folder of the project that we just created. We will be adding some properties to this file. We'll first add eureka.instance.hostname, and depending on where we want this discovery server to run, we can specify that particular host too. For now, we'll be hosting it on localhost. Now we have to make sure that it does not register to itself as a service. For this, we'll add eureka.client.register_with-eureka is equal to false. We also have to make sure we are disabling fetch registry. To do so, we'll declare eureka.client.fetchRegistry is equal to false. Then finally, we'll also declare the server port and specify an empty port where there are no services running presently. We'll use port 6767. Let's save these properties. Now we will enable our class or application to behave as a discovery server. So let's open up the boot application, which was created along with the project, and we will annotate it as Enable Eureka Server. Let's run this project as a Spring Boot app. We can see on the console that this application has started on port 6767. We'll verify this using a browser. The service is running at localhost and on the port 6767. We can see that our Spring Eureka server is running successfully and is ready to use. As of now, there are no clients bound to it. Let's create another project and provision it as Discover Service to bind with our Discovery Server. We'll follow the same process of building a project that we used earlier. We'll name this project as Exercise 3 Client and add the same components and dependencies as before. Click Finish to complete building this project. Now we need to edit the resources, and this time we'll rename this application.properties file as application.yml file. We need to specify the port at which the client will run the Eureka server with which it has to communicate along with the name. To define all of these, we'll be adding some properties to the application.yml file. Let's import the code that can configure the properties. Change the port to 8099 so that there is no conflict, and ensure that the particular port is similar to the port at which your Eureka server is running. Our Eureka server is running at port 6767, so we'll specify this port to 6767. Save these properties. We also have to ensure that our project is treated as a Eureka client, so we'll bring up the application and enable Eureka Client. Now this application will look for Eureka Server, and it will bind itself as a service to Eureka Server. Let's run this as a Spring Boot app. After the service starts, we can navigate to the Eureka Server to verify that this service is discoverable at the Eureka Server. Let's maximize this browser for a better view. We can see that our service is bound with this particular Eureka server. And this is how we will create a discovery server, build a discovery service, and bind it with that particular discovery server.